terrific group of individuals who have been thinking about and planning this rendezvous since early this year. It's been a 5-month, 6-month exercise now rather than the 2-day exercise, so extra vigilance by our steering committee members. And I also want to thank the numbers of organizations that have helped make this series of webinars great. The presenters, the supporters, the planners. You can see it's a diverse group from not only a lot from Colorado, but from all over the West and indeed all over the country. And we thank everyone that's been part of making this special. So before we kick off, I just want to go over a little bit of our ground rules for those of you that have joined us. This is repetitive, but I'll be brief. First of all, we're going to record this as we have recorded all of the other webinars. They're available to watch at the Friends of the Yampa website, friendsoftheyampa.com. So if you want to watch this again or go back and see any of the earlier ones, that's a great place to go do that. In terms of today's, all of you who have joined us are muted, but we do have the ability, and we want this to be an interactive discussion. So as people are speaking, use the question and answer function at the bottom of your screen to type in a question to the panelists. We'll, if we have time, we'll have direct questions for each panelist as they finish, and then a substantial chunk of time, at least 30 minutes at the end, for all 3 panelists to respond and talk to each other and going forward. If you'd like to ask your question in person, you can use the raise hand function. And the chat function here should be used, doesn't go to everyone. It's if you're having trouble understanding or hearing or seeing things, we can connect you with some of the organizers who can answer those questions. So, and if you're on the phone and not on Zoom, you can press *9 to be put in the queue for asking questions and answers. And so with that, I would like to introduce you to the topic of today's webinar, which is shifting seasons. The overall thing is the uncertainties and impacts of seasonal variability. As we've explored in earlier webinars, there are at least 3 big things we know we face with climate change here in the Yampa Basin and around the world. The first is, well, change, right? We know that things generally are going to be moving in the direction of hotter and drier, as we've obviously experienced this summer. So that's one thing, is that change. A second thing is increased variability year to year and within seasons within that change. So things we've been able to count on in the past are no longer the normal pattern. And third, on top of both of those trends, change and variability, is uncertainty. Our ability to predict are more challenged. And then those that are dependent on natural cycles and natural resources for their businesses and livelihood and for natural systems, our ability to plan and adapt is made much more complex with this uncertainty. So today we'll explore a bit of all 3 aspects, all of those 3 aspects of attributes of climate change. We're going to begin with exploring sort of our limits of predictive ability and the uncertainty of those. And then we'll explore the impacts of that to both our natural systems and our agricultural systems in Colorado, and beginning to explore what we can do to adapt. So let me give you a quick overview to our excellent panel today. First, we will have Dr. Aneesh Subramanian from the Department of Atmospheric and Oceanic Sciences at the University of Colorado in Boulder. Second, we have Dave Anderson, who's the director of the Colorado Natural Heritage Program based at Colorado State University in Fort Collins. And finally, we have Todd Hagenbuch, the Routt County Director for Colorado State Extension Service. Todd and Aneesh have both been participants in our prior rendezvous, and we're great to have Dave here. It's also nice to have such outstanding representation from 3 distinguished Colorado institutions. So we will begin first with Aneesh Subramanian. Dr. Subramanian's research interests are mainly in climate processes, global and regional weather and climate prediction, and coupled ocean atmosphere data assimilation. He's a climate scientist who studies the predictability of global weather systems such as atmospheric rivers on medium range to subseasonal timescales, and oceanic influences on prediction in these timescales using both computational models and observational analysis. Dr. Subramanian received his PhD from the Scripps Institute of Oceanography. He was a postdoctoral fellow in the physics department at the University of Oxford, and he then joined the Center for Western Weather and Water Extremes, one of our key partners in this rendezvous from day one, as a project scientist to lead their efforts on subseasonal prediction and data assimilation to help improve Western US extreme weather predictions. And Dr. Subramanian was part of our first webinar as in his role at the Center for the Western Weather and Water Extremes. Dr. Subramanian joined the Atmospheric and Oceanic Sciences Department at CU Boulder in 2019 and continues his research there on prediction of our Earth system from weather to climate timescales, as well as understanding of climate processes. Dr. Subramanian is the author or co-author of more than 60 refereed publications, and we're very pleased to have Aneesh back to join us at the rendezvous to give his perspective on our ability to predict and deal with uncertainty in our projections. So we'll turn it over to you, Aneesh.
Thanks very much, Tim, for the kind introduction. And thank you again for this opportunity to present to the group. I'll start sharing my screen. Okay. Great. Yeah, I was part of the first Yampa Basin Rendezvous, I think, in Steamboat, and I really enjoyed it. And there was one experience of going back. It was both a really fun science experience, but also a really fun social experience, meeting everyone there and in a beautiful location. So it was the best combination of everything. I hope we can come back to it next summer. Hopefully, if not, at least the summer after. So today my talk will be on how the seasons are shifting and what are their implications both for water resources in the West as well as some of the ecological impacts. I would like to acknowledge my collaborators in this. I've got input from Kristen, Tamara, Sasha, Anna, and Marty, who are at CW3. And I wanted to start with this really beautiful two-line poem that I came across. It's a Native American poem from the Chippewa tribe. It goes as my eyes search the prairie, I feel the summer in the spring. It's a beautiful two lines implying a lot of different things, like coming out of winter, looking out into the prairie, and thinking about the warm summer as things are blooming in the spring. So that's a theme that I'll be pulling on through this talk on how the seasons are changing and how the seasons are likely to change with climate change, with how the nature responds to anthropogenic forcing that we are putting into the atmosphere. So as a first study, I wanted to highlight this really nice, beautiful paper that pulls together both climate aspects of seasons as well as ecological aspects. This was led by Dan Cahan, scientist at Scripps, well-renowned scientist at Scripps. So the paper came out in 2001 on the changes in the onset of spring in the Western US. And they had a beautiful study of like combining blooming dates of lilac and honeysuckle. They had like a network of phenological observers around Western US who timed when these plants were blooming and when the flowers were blooming. And what they did was then to correlate this timing of the blooms with other climate variables such as the snowmelt pulse, so when the snowmelt comes down, as well as temperatures in the Pacific Northwest. The key findings of this study is they say the fluctuations in the lilac first bloom dates are highly correlated with those of the honeysuckle plants, and then both are significantly correlated with those of the spring snowmelt pulse. And since the 1970s or late 1970s, as shown in this blue box, what they observed is that the onset of spring has been remarkable, like it's been changing, and they reflect the unusual spell of it becoming warmer than normal in springs in Western North America during this post-1970s period. They attribute, and they show really nice analysis in the paper of like this warm episodes in early spring are related to atmospheric conditions that are changing over North America as well as the Northeast Pacific. But in that paper, they don't conclude whether this is because of climate change or it's part of the natural variability in the system because of decadal changes in climate. So I'll show some more recent results, which are showing more and more evidence that some of this at least is climate change driven. There is still large uncertainty as the theme of our session today. So one thing to recall about the West is the precipitation in the West is the topography of the mountains are really crucial for how the precipitation is distributed in the Western US. And this is key for how the water resources are stored in the natural mountains, and then how that then is supplied down to us as part of snowmelt and then river runoff and river flow. So the plot here is showing how the annual mean precipitation is distributed across the Western US. And what we see is a lot of the precipitation is along the mountains, the Sierra Nevadas and the Rockies. And how this precipitation changes, as well as how the melting of the snow that accumulates on the mountains will impact how water is then supplied or distributed across the Western US. This is a plot from a Colorado climate change report that came out a few years back. And what they show in this study is from observational records, what we are seeing is that the daily minimum temperatures as a function of elevation. So this is as we go higher up into the mountains, the daily minimum temperature trend is increasing at higher elevations more so than lower elevations. So the temperature trend, let's say at 12,000 feet or 10,000 feet up in the mountains, the increase in temperature over those 3.5 decades has been more than in the lower elevations. So what that implies is that if this continues and this increases, that the higher elevations have higher amount of temperature increase, that would imply a big change in terms of snowmelt and runoff, that we would have earlier snowmelt and runoff with warmer spring temperatures. So this is another study looking at how what's known as center timing. So they do a mass weighted timing of how snowmelt comes down the mountains into the watersheds. They calculate this over a 50-year period from the 1950s until 2000. And what they observe is that this center timing of when the snowmelt is happening and when it's coming down, it's been changing to advancing by 1 to 5 weeks earlier in the US West. So that was like our observational, what we know from previous records, like over the last 5-6 decades, how things have been changing. The spring has been advancing. There's warmer temperatures in spring, and in terms of implication that there's more snowmelt earlier in spring, and it implies for the runoff as well. There's earlier runoff. So in terms of future projections out into the next century, this is a study led by Eric Maloney, who's at CSU. They look at the CMIP5, which is the climate model intercomparison project that happened about a decade ago. And they look at how temperatures are changing as well as precipitation is changing. On the left, it's temperature, and on the right, it's precipitation. The regions that are hatched in this plot is regions where the models don't agree well. So that's regions where there's uncertainty in how things are exactly going to change. But what we see in terms of precipitation is that the Southwest US and North America, there is a net decrease in precipitation. But then the increase in precipitation happens in the Pacific Northwest. There is uncertainty in some part of the Western US region from these modeled results. That's something that needs to be tackled, whether that's uncertainty from just the models not being able to resolve some of the processes, or it's true uncertainty in nature. In terms of temperatures, what we see is it's going to warm everywhere, and the warming especially in winter and early spring, the polar warming is much more than in the tropics. So that would imply a lot of change in terms of how the polar climate can interact with the mid latitudes and subtropics where the regions in the Western US are. This is a plot showing what does this imply for the snow water equivalent, SWE, also known as SWE. So on the top left panel is the CMIP5, so the climate model ensemble change at the end of this century minus 30 years of the last century. And what that is showing us is that the total amount of SWE will decrease in these models largely over the Western US region. And then focusing on the Southwest or the Western US region, this is a plot showing just the April month SWE. And even in April, what we see is that there's a big amount of decrease in terms of snow water equivalent, which would then imply lesser amount of supply of water to the Western US. And then just a recent study that I collaborated with a really great postdoc, Hege Biete from Sweden, and a couple of scientists from NCAR and NOAA. We looked at how ENSO or El Nino is going to change in the most recent climate models, CMIPS6, so the next generation climate models. This just came out this year. And what we see is that the ENSO is likely to change in terms of teleconnections from the tropical Pacific into the Western US region. So what's plotted here in the color is the sea level pressure. For El Nino on the left, we see this large low pressure region in Aleutian Low, and that's a known teleconnection pattern. And during La Nina events, this has the opposite sign where the pressure is higher off the Alaskan coast in the Aleutian Low region. The line contours are showing the change in the future. So the end of this century, how would these pressure contours change? And what we see is that the pressure is going to increase. So the deep low pressures will not be as deep as projected by the latest climate models. And there is a difference between how it would change in El Nino versus La Nina, and that has implications in terms of how atmospheric circulation will change as well as precipitation will change. This was just published this week actually in GRL. And this has a lot of implication in terms of how both the climate in the West changes as well as how the seasons will change, because this is largely a winter and spring event. So now I'll go into the impacts of these changes in the seasons in terms of spring temperatures increasing, precipitation decreasing, the timing of the seasons are also changing. What does this mean for the ecological systems in the Western US? So As you know, living things are intimately connected to their physical surroundings, and ecosystems are affected by temperature, precipitation, as we just mentioned, as well as in the ocean or the freshwater systems. They're affected by acidity, salinity, and activities of other species around them. In terms of how it would affect plants, agriculture, as well as natural vegetation, the plot on the left is showing historical records of how plant hardiness has been changing. And what's been seen is that most of the hardiness zones are shifting northward over the last 3-4 decades. On the right, what's shown is again from the Maloney et al. Study, Eric Maloney's study from the CMIPS-5 climate model projection into the next century, into this end of this century. And what they are saying is that that the growing season is likely to lengthen as per all these models. And that's based on the minimum temperature, the end of the last freezing and the beginning of the first freezing of the next autumn, fall season. And then in terms of how this would affect other species as well. So something that's been observed in this National Academy report is that trees are blooming earlier, 15 to 20 days earlier, migrating birds are arriving earlier, butterflies are emerging earlier. On the right, it's just one image of a bird, a European pied flycatcher. Chicks are, they've noticed they're being born later than the caterpillars they eat. So that has an implication in terms of how different species interact with each other and what climate change and seasons changing imply for this. And then in terms of impact on humans, this is study led by Sasha, Kristen, Tamara, Shulgina, who are at CW3, and then one recent study by Schwartz et al. 2020. So in terms of heat waves and what that implies for human health, what's been noticed is that the summer is the season that's most associated with heat waves, but in terms of human impact and how hospitalization numbers change due to heat waves, it's been noticed that in spring, like in the month of May, if there are heat waves, so the first set of heat waves of the season, that is when most people are likely to have a health impact and likely to be hospitalized. So the plot on the right is showing odds of hospitalization during extreme heat waves. And what they see is that the spring season is when the number of hospitalizations are increasing. So if the spring temperatures are likely to change and if the spring is going to start earlier, that again has implications for how this would impact human health. Another thing that's been seen, this is work done by Tamara, Shulgina, and co-authors. They plot the minimum and maximum temperatures for different months. And what they see is like in late winter, early spring, so in March, as well as in other months of the year, the minimum temperature trend is increasing greater than the maximum temperature trend. What that means is, like, for instance, if there's a heat wave, or like if there's higher temperatures in March, the nighttime will not cool as much, which is one thing that would give respite to the people who have health issues, right? So that also has implications for human health. So with that, I don't know how long I took, Tim, sorry. Am I on time? I'll just summarize quickly. And
yeah, just wrap up.
Great. Okay. Yeah, so in terms of changes, there's robust agreement in terms of the Western US is going to warm, the temperatures are going to increase. Precipitation changes reflect a drier Southwest US and a wetter Northwest US. But there is uncertainty in model projections, as I showed. So there's still more work to be done in terms of disentangling these signals. Spring seasons start earlier and hence warm temperatures arrive earlier. Snowmelt also happens earlier. And overall, there's a decrease in the amount of SWE, the snow water equivalent over the Western US. Impact for vegetation, the plant hardiness is changing, and we're likely to see more of that in the future decades. The length of the growing season also is changing. In terms of impact on human health, just like I mentioned previous slide, spring heat waves could increase and hence increase in health burdens on the population and hospitalization increases. So, thanks.
Thanks,
Thank
Anish.
you, Aneesh. I just have one quick clarifying question, and then we're going to move on for the sake of time. We have all the other questions we'll address at the end. So someone asked, please define plant hardiness.
Yeah, so probably the speakers who come after me have a better definition about this than me. I think I'm not an expert on ecology and plant physiology. So I'll probably hand it over to them to define it properly. I have some understanding, but probably not an expert's understanding.
Lindsay, do you want me to answer that real quick?
Yes, that would be great.
Todd.
This is Todd Hagenbuch with the Extension Office. Plant hardiness is a function of how well a perennial plant or tree, any sort of plant, will survive cold winter temperatures. So it's not a function of how it grows in the summer, but its survivability over cold winter temperatures. And so when Aneesh talks about hardiness zones climbing, it means the maximum cold temperature we can expect in an area over a winter season.
Great. Thanks, Aneesh. We'll look forward to coming back to conversation. Our second speaker is Dave Anderson. And Dave is the director of the Colorado Natural Heritage Program based out of Fort Collins at CSU. In that role, he spends most of his efforts on program coordination and outreach and on developing new projects and initiatives for the program. He has a background in botany, so he can also talk about plant hardiness, and has worked throughout Colorado studying rare plants and plant communities. Prior to coming to Colorado, he worked in the Alaskan and Canadian Arctic on botany field projects and was a Peace Corps volunteer in the Solomon Islands and in the South Pacific. I will just add that CNHP has been an incredible valued partner of the Nature Conservancy here in Colorado. I had the honor of working with Dave and his team on a number of really interesting projects looking at climate impacts and what we might do about them. And I'm looking forward to hearing about that a bit from Dave as well today. So let's take it over to you, Dave.
Okay. I think it's going to let me go ahead and share. Here we go. Okay, are you seeing my screen?
Yeah, looks good.
Thank you so much for the great introduction, Tim, and thank you all for the honor of being here to be a part of the Yampa Basin Rendezvous. I'm really excited to join you all and really excited to share some of the stuff that we've done in trying to bring a sort of climate change modeling and data like Aneesh has shared into focus for natural heritage conservation. So conserving the nature that we have inherited and are therefore the stewards of. Everything I'm going to show you was done in one way or another in partnership with the Nature Conservancy, also with a broad range of different partners who I'll talk a little bit about. So this is what I'll show you is kind of rolling up a work of a lot of different people. With myself really principally as a talking head when it comes to expertise on these things. So I'll do my best to answer all of your questions. So the Colorado Natural Heritage Program, wanted to give you a quick background of what we are. We are a soft-funded program based at Colorado State University and the Warner College of Natural Resources. And we have kind of a double identity at CNHP. We are part of the university. We're also part of this network that was created by the Nature Conservancy in the 1970s, now unified under a nonprofit called NatureServe. And so we work closely with NatureServe on lots of different efforts, including climate change. The NatureServe network has a heritage program based in all US states and Canadian provinces and in most of Latin America. So the things that we do as a heritage program are to support conservation management and development using science information and data as purely a scientific organization, not involved in advocacy per se. And the way that we do that as a heritage program is to answer 5 key questions. And those are basically, what do we have in Colorado? Which ones are at risk? Where are they found and how are they doing? And then rolling it up to landscapes where we can identify the most important and urgent places to protect. And through that science, we help to provide the decision quality data that our partners can use to actually do the conservation on the ground, which we are not formally involved in. We don't own land or manage land at our program. So you can imagine that bringing climate into focus to conserve our rare species and our natural heritage in Colorado, it's critical that we start thinking about climate. So we are endeavoring to bring climate change into focus for all of the projects that we do at CNHP now, insofar as we can. So this is a little diagram. So Tim asked me to talk about vulnerability and tell everyone kind of how we're dealing with that in this space of natural heritage conservation. So this is our Bible for assessing vulnerability, this Scanning the Conservation Horizon, published in 2011. This simple diagram on the right kind of shows how we think about vulnerability for species. So the environmental factors, exposure and sensitivity, exposure being the environmental factor and sensitivity is the sort of ecological response of ability of a species to respond to changes in its climate envelope, roll up to potential impact, and looking at a species' adaptive capacity, which has a lot to do with how much can it move? Are there places it can go to reduce exposure to climate? And looking at all those factors together rolls up into vulnerability. So that's how we think about vulnerability for the conservation work that we're doing. So we've been using a tool that was developed by scientists at NatureServe called the Climate Change Vulnerability Index, which is really nifty. It's a very simple tool. It runs in an Excel spreadsheet, and you go through it for a species and assign scores, sort of kind of Likert scale type scores for each of these different factors. And the tool rolls it up to give you an overall score. We really have liked this tool. It helps, it's coarse, but it gives us a really good sense of sort of the relative degree to which we need to worry about a particular species in the face of climate change. So we've put this tool to work to do some statewide assessment of climate change vulnerability that was funded by the Colorado BLM back in 2015. And for that, we assessed 36 animals and 62 plants using that climate change vulnerability index. And we also assessed 16 terrestrial ecological systems. And for those, we used a thing called the HCCVI, the Habitat Climate Change Vulnerability Index, which is similar to the CCVI, but includes some factors relevant for thinking about ecological systems. So I'll show you how that came out. And I should also tell you that the 98 species were some of the highest priority species for conservation in Colorado, so they're very rare. When you break it down for plants, things didn't look so good for those set of 68 species that we looked at. Almost all of them scored in the CCVI to be extremely vulnerable. So for those species, the combination of all of the vulnerability factors leaves them extremely vulnerable to climate change. Most of them have very small ranges or are found on a very particular kind of geology where they may not have refugia where they could potentially hang out and not be so exposed to climate change. There were 3 species that came out as only highly vulnerable and 1 that came out moderately vulnerable. So I wanted to put this into focus with a species that's found in the Yampa Basin. This is the narrowleaf evening primrose, Oenothera acutissima, that's found out in western Moffat County on sort of in sagebrush shrubland habitats. It also gets up into Wyoming and Utah, so its range is not limited to Colorado, but this one is a G2S2. It's a globally rare species, with a very restricted range. So looking at this species through the CCVI, I'll show you what those results were, and also want to show you this picture. This is from T. Wright Dickinson's ranch out in western Colorado with Jeff Blakesley. I bet some of you all know Jeff, who worked for many years with Nature Conservancy and was a wonderful partner for us. So T. Wright's on the left, Jeff's in the middle, and Renee Rondeau, our senior ecologist at CNHP, is on the right. And in the middle, you see the Oenothera acutissima. The plant lives across a fairly broad range of different kind of habitats. We found a lot of it in these rocky spots where the cattle couldn't seem to really get to. There had been a petition to list this species, and this work that we did on T. Wright's ranch and elsewhere kind of helped us provide feedback to Fish and Wildlife and others that the plant was probably going to be okay, and that the grazing regimes it was exposed to were not going to drive it to extinction. So when we crunched that species out, it was one of the 3 that came out to be only highly vulnerable instead of extremely vulnerable. So most of the other species, as I said, almost all of them came out as extremely vulnerable. This one had just enough kind of variability in its habitats and a big enough range that it didn't make it into the most extreme category of vulnerability to climate change. So another thing, looking at the animals in this assessment, we looked at where the cold to warm water transition line is, which is shown in green on this map. And then looking at different representative concentration pathway scenarios where that transition line was going to move to. And so that spells some pretty scary stuff for Colorado's fish. Most of our money generating fisheries are cold water fish. Most people come here to fish for the trout that are found in the cold waters. We're going to lose by mid-century a lot of cold water fishery area in Colorado. So needless to say, the fish in the analysis scored very poorly. They were extremely vulnerable in most cases. Looking at the ecological systems statewide, here are the ones that came out to be most vulnerable: the woodlands and shrublands along rivers and streams on both east and west slopes. That one's not a surprise. Shortgrass prairie also came out to be highly vulnerable. The wetlands of the eastern plains. This is a playa. And then pinyon juniper woodlands also came out to be very vulnerable. And so since that one's in the Yampa Basin, I wanted to kind of examine that one a little more closely. The way that we're looking at these ecological systems is through this kind of flowchart model to figure out which ones, which of these systems in what areas we think are going to be persistent, where mid-century climate indicates that we might still be able to have that ecological system in a particular place. Emergent ones are places where it's not currently suitable for that ecological system, but it will become suitable under climate change scenarios. And then threatened and lost are where it's going to get too warm or dry to still have that system in a particular place. So we're going to lose systems in those places. And what that looks like, what those transformations look like is still a little bit mysterious to us. We don't know if that's going to happen sort of catastrophically through fires or incrementally through plants sort of moving in and changing, probably some combination of those, of both of those. Managers have a huge opportunity here to use these data to make decisions on how you manage for something. If we think the system's going to be persistent, then it makes sense to manage for that system in that place. But if climate indicates that we're going to lose it, then it's an opportunity for us to be thinking more about what we think that system's going to transform into, and think adaptively in how we manage. So there's a lot of different climate models out there, and getting your head around these has been a really gnarly challenge for us. Fortunately, we have had some great help from Dr. Imtiaz Rangwala, who's one of Aneesh's colleagues at University of Colorado. And Dr. Rangwala has worked with our team and folks at TNC and elsewhere to help us kind of get our heads around how can we kind of boil all these models down and think about them in a way that we can sort of put into a management framework, and look at these models sort of holistically. So here we have temperature on the y-axis and precipitation on the x-axis, and these 34 general circulation models that you see shown here represent different representative concentration pathways of CO2 levels, and kind of form this scatter on this diagram. And so with Dr. Rangwala, we identified these 4 different scenarios, kind of a hot and dry where it's really hot and really dry, a hot and wet set of scenarios, a warm and wet where it's not quite as hot, but precipitation increases, and a feast and famine set of scenarios where there's a lot of variability between years.
Dave,
So,
Dave, a few minutes left if you could.
Okay,
Yeah.
I'm just about done here.
Sure.
We also looked at the systems through these biological niche models, looking at where a species or where a system is now, looking at the sort of climate space that it exists in now, and where predictions indicate what the conditions will be like where that system is by mid-century. So this is an example for the pinyon pine. Zip through these. So when you take those 4 different scenarios and look at pinyon pines and where they are now, here's how those pencil out. In the hot and dry scenario, you can see in the Yampa Basin, there's a lot of threatened or lost pinyon pines in the western side of the basin. And those scenarios become less dire in the warm and wet scenario on the lower right. Then the last thing I'll just very quickly introduce you to was the happy story. I like to end on a happy note. So we've worked with a broad range of partners to kind of put some of this on the ground, and are playing a role in this Gunnison Basin Working Group, where we've looked at brood-rearing habitats for the Gunnison sage grouse, which is a very rare species of grouse in the Gunnison Basin, and identified that through this work that the headwater wetlands and sagebrush shrublands were really the pinch point for this species, and that restoration that we could do on these sagebrush shrublands was going to help them rear their broods successfully and keep do some really important conservation for them. So working with this group, structures have been built in over 400 of these headwater wetlands using simple natural substances, logs and rocks, following methods of a gentleman named Bill Zedike to stabilize these head cutting and degraded headwater wetlands. Here's we're doing the monitoring of a lot of these structures, and here's the one that was being built in the previous picture, looking at it from 2013 to 2019, and you can see how the structure has caused the head cut to fill in with sediment. We've seen a lot of transition from upland plants over to obligate and facultative wetland plants through these transformations as well. So the wetland characters of these headwaters areas are coming back. So these methods are starting to be used much more widely across the West because it really seems to work. So that's what I had to share with you, and thank you so much.
Thank you, Dave. So we're going to hold, for the sake of time, we're going to hold some of the questions at the end. There's a lot of great ones. So stick around to the end, everyone.
Great. Thanks, Lindsay, and thanks, Dave. Yeah, I'm glad that it's putting all of these pieces together and thinking about what this looks like on the ground is both helpful, but also daunting. And I think we'll get a little bit more of that now with our final presenter today, which is Todd Hagenbuch. He's the Ag Natural Resources Agent and the County Director for Colorado State University Extension in Routt County. Todd's is the fourth generation of his family to ranch in Routt County. He's been working with Extension Service since 2012. He handles all manners of agricultural issues that we face up in this part of the world, including small acreage management, weed identification and control, rangeland management, and more. Todd received his BS in Farm and Ranch Management from CSU and his master's from Regis University. And we're thrilled to have Todd join us again at the rendezvous, and one of our incredibly valuable local partners in thinking about all these issues in terms of land management and climate change. So turn it over to you, Todd.
Many thank you, Tim. I appreciate that. We'll share our screen here. Tim, can you confirm that you're seeing that?
It's looking good.
Excellent. Thank you all. Well, I don't have all the cool charts and some of that great research information that the previous speakers have, but we're going to take a little trip down memory lane here in the next 20 minutes and also talk about what the future looks like as we talk about seasonal variability and changes to our local agricultural way of life. Note here first, I want to introduce you also to the fifth generation of my family. So this is my wife, Sarah, and my kids, Trevor and Amelia, enjoying all those beautiful outdoor landscapes that, of course, the Yampa Valley has to offer last winter in our plentiful snow on a snowshoe. And I'm excited for them to have the opportunity to grow up in Routt County, but also must admit that I wonder what the future will look like, especially as we look at the opportunities and the challenges agriculture will be faced because of a changing climate. So, short history of agriculture in our valley. Remember that President Lincoln signed the Homestead Act back in the 1860s, and that enabled willing and certainly hardy folks to come out to the West and claim their 160 acres of homestead. They had to prove up on that land. They had to build a home there. They had to ensure that they could have a business there that was viable. And then the patent would be released to them and they would own that 160 acres. Now, our area was homesteaded, started in the late 1800s and continued through the early part of the last century. Really then how that all seemed to work was that people would come out, they'd get their 160 acres, but realize that in our climate, our certainly semi-arid climate, that it was difficult to have a self-sustaining ranch or farm on 160 acres. So what that meant is that those that were a little bit more successful maybe got a little better claim on their 160 acres and were able to be a bit more profitable, soon started to buy out those that were less profitable, and that led to the consolidation of homesteads into larger, more profitable, and more sustaining agricultural operations throughout Colorado. Bear in mind too, though, that wasn't just the private property that made those ranches work, but public grazing. And that's always been a pretty strong component of agriculture in our area, including not only BLM pieces that are typically pieces that were left over that weren't homesteaded on, but also included the U.S. Forest Service land that so many cattle and sheep still graze and use that forage. And why is that important? Climate variability is changing and can change what that forage capacity looks like on both private and public properties, which can change the profitability and the margins that we are able to sometimes experience on our ranches. Development pressures, of course, began in the 1970s and persist to today, especially I think the last couple months. It would seem that we have been found by a new wave of folks who want to live here. And so those development pressures will continue. But that also means that we have smaller acreages than we used to. We've gone we consolidated, we got bigger ranches, bigger farms, and now we're going the opposite direction and we're subdividing things back out again. And that means that there's some opportunities, but it also makes for more challenges as we look at climate changes and how we adapt, because we have fewer acres to try to work with. That can prove challenging. Also note that some of our large acreages that have stayed together and haven't been subdivided are now typically owned by people who aren't agricultural producers. They either hire a manager or they lease the ag rights out to someone else. I love this photo. This is a photo of Mount Warner. Looked very much this way when my grandmother and her family lived at the base of Mount Warner and grew vegetables for the local Safeway store back in the 20s and 30s. So what does history tell about the climate and that agriculture? So bearing in mind how that all worked and that agriculture has many challenges, how about climate and how has that climate influenced what has happened here over the years? Well, if you're new to the Valley and you haven't had this opportunity to understand why Strawberry Park is called Strawberry Park, it's because we used to grow lots and lots of strawberries, again, in the earlier parts of the last century in Strawberry Park. So many, in fact, that we exported those. This is a picture, courtesy of the Steamboat Pilot today, of people picking strawberries in Strawberry Park. And then there was also a very large lettuce production component in Routt County, specifically South Routt County. And we're going to dive just a little bit into that to talk about that climate history. So this is a great article from the Routt County Sentinel, which was a newspaper here locally back in the 20s, the 1920s. And this is an article from November of 1923. So just about 100 years ago next month, 97 years ago next month. And I love these quotes as we talk about lettuce production. If you haven't paid attention as you drive south on 131, particularly between Yampa and Toponis, look off to the left side of the road or the east side of Highway 131, and you'll see an interesting wooden structure along the railroad. That is the old ice elevator. And if you have an elevated vehicle, you can see that there are still some ponds behind that wooden structure, which is where they cut ice all winter, stored in large sheds on sawdust, the ice, and then use that ice to transport this lettuce that we see being grown here on the top right picture to places all over the country. In that year, Yampa sent 254 carloads of lettuce, primarily to the east. The Waldorf Astoria Hotel, it's rumored, loved Yampa Valley lettuce. But why I talk about this is climate variability was an issue back then. I'm going to read this. I hate to read from a PowerPoint directly, but this is a quote from that paper in 1923. It is certain that next year, head lettuce will yield still larger returns to Routt County, as there will be an increased acreage and a larger production per acre that can be depended upon. This summer was an unusually unfavorable one on account of the long continued rainy weather. About 500 acres were in crop in the county, but fully 1/3 of the yield was lost. And in a normal season, there will be much better production marketed per acre. For the first time, the lettuce buyers of the country this year became acquainted with the superior quality of the Routt County product, over 4/5 of which was raised in altitude of from 7,900 to 8,500 feet. This won instant recognition as being the best on the market, despite the unfavorable conditions prevailing this season, and is certain there'll be lively competition for the crop of 1924. So why is that important? Looked at back then, 97 years ago, they talked about we can depend on different weather next year. They lamented the amount of rain they got that year, and then also referred to a normal season. My contention, of course, is that we don't have a normal season in Routt County. That variability has been something that we've always dealt with. But the question is, will climate change make those variables higher, lower, and more often? What does my history tell me? This is my grandmother, Elaine Gay, in the top right picture, and then my grandfather, Bob Gay, in the lower right-hand picture with the team of horses. My history tells me that we've had droughts in the past. My family talked about at length the droughts of the 1930s and the 1950s that affected agricultural production in Routt County, long dry periods. And also, they talked often about the January thaw or the February thaw that would come along. Now, what's interesting is that January and February thaws, I think now tend to be a little warmer, a little longer. But what's interesting back then, people may not realize, is that the Yampa River would freeze over prior to the damming of the river at Lake Catamount and Stagecoach Reservoir, and that the river, when it was frozen, was used as a bit of a transportation corridor early at the change of the last century. And also ranchers would cross the river to feed their cattle, and bridges weren't in plentiful supply back then. So those January and February thaws could really throw you for a loop if the river started to thaw out and you couldn't cross it. But what was also more common than those January and February thaws were negative temperatures. I know my dad talks about the first time he came up to Christmas of 1970 to meet my mother's family. My grandfather looked out the window at the thermometer and said, "Oh, it's 40 below, and you can bet it's another 5 to 10 degrees colder out on the river where the cows are." So that is something that we've definitely seen change. In the last 20 years, we haven't gotten that cold, period. And that changes how we look at ag production as well. But we don't have to look back that far to see what variability looks like. Does anybody remember 2011? Not very long ago. These are some pictures at our place. The lower left-hand corner there is the confluence of the Yampa River and Morrison Creek, right below Stagecoach. That's part of family ranch. It's actually the only part that still remains part of the family. But that was a year that saw super increased flows. We had a huge snowpack that year. So much so that here, this is Green Creek had washed out the road to my grandmother's house, and we were trying to just get her to Mother's Day brunch. We had to time it for brunch and not dinner that year because the creek came back up in the afternoon and we couldn't have got her back into her house. So huge water year. How about the next year? If you want to talk about variability, look at 2012, one of the driest on record. This was a mere 13 months later after things were flooding all over the county. And here I had a full house at the drought workshop co-hosted by Extension and the Community Ag Alliance as we dealt with unprecedented historic dry conditions. So that variability that we've dealt with for all these years, how do we adjust to that as an ag producer? First, we don't run at capacity. So of course, profit would say, or economics would say, that you maximize the use of every acre every year. But we know that in order to withstand the variability, we have to have that cushion. We have to have extra pasture land, either in leases or some other means, and we just don't run as many cattle as we'd like to, and as cattle, sheep, or any other browsing animal. We carry over hay from year to year. So those really good years, like last year, 2019 was an excellent hay production year. 30% sometimes were better, an average in terms of production value of forage. So we carry some of that over. But the number one way we adjust for variability is irrigation. We'll talk more about that in a minute. But things we also have to consider is that regardless of what Mother Nature is doing, cattle cannot be sold at just any time. So I say have timing on there. If you have cows that are pregnant with calves, you can't just ship them right before they're ready to calve. And conversely, you can't ship them right after they've calved either. You have to plan in advance. And too often, say this year being a perfect example, you go into winter with lots of extra hay. You have extra cattle. You think things are going to be great. The winter was fantastic. And then this summer hits. And all of a sudden, you find out you're overstocked. You can't just turn around on a dime and sell cattle. because of all the things that go into it, including the genetic resource that you have there. So maybe the timing isn't good, but also you've been working for many, many years, decades oftentimes on these ranches to make sure that you have a genetic resource that that works in this climate, and selling that sometimes does not work. And then also markets. Of course, we're looking at markets. I don't know if you read yesterday's pilot article that featured some of our local ranchers. Jim Stanko noted that we're back to 1985 prices. So in a very tough year like this, when you're also forced to liquidate part of your herd at greatly reduced prices, that is a double whammy. So I want to go back to this irrigation. I said irrigation is one of the main ways we've managed and mitigated variability for years. And bear in mind that initial water storage in the valley was for irrigation. That's why Stillwater Reservoir was initially conceived. Allen Basin, same way. These are up in the upper reaches of the Bear River above Yampa. Of course, Yamcolo, same thing, even though it is for electrical uses as well, or power plant generation. It was initially conceived as water for irrigation, and Stagecoach has an irrigation component. But I'll note too, what was the first way and the major way we still store water in the Yampa Valley? And that's through snow. And this is why we have a major concern with additional climate variability and climate change, warming temperatures. As Aneesh talked about, if we don't store as much snow as possible throughout the winter seasons, and or the timing of that snow and its release is different because of melting, we don't have the ability to mitigate the temperatures that we're experiencing now in the summer. Irrigation is exceptionally important. And here's an example of how we store water in snow. Top right pictures Walton Creek at the Windsor Ditch Headgate in mid-June. And then here just 4 months later, the Walton Creek drainage right there at the same point. Look how little water there is. It's because there's just simply no snow. We don't have storage other than snow. So when you mess with the amount of snow we get and the timing of its melting, you greatly impact how we're able to mitigate the other variabilities that we're dealing with. So what does our history tell us about irrigation? So, you know, it's interesting to note that most of the valley floor has never been plowed. People think that those are grasses we've planted. Some they are. They were mostly overseeded during times, but most of those valley floor, excuse me, that we have here in Routt County in the Yampa Basin has never been plowed. Those are a lot of native grasses. The species composition has changed due to irrigation, but still a lot of native grasses. We probably had, prior to irrigation, more wheat grasses, intermediate western things of that nature that like a little drier feet. So that's changed a little, but it is mostly the same. Irrigation impacts, though, and we need to talk about how irrigation has positively impacted the area. We do store a lot of water in the valley in the soil throughout the summer. And you only need to go downstream to talk to people about that. I went with Dr. Tim Gates from CSU down to Moffat County. We talked to some producers down there here a couple years when we had our Miracle May. I think it was 2014, and it rained nearly every day in Routt County. And so we didn't turn on our ditches. Go down and talk to the producers down in the Maybell area, and they will tell you that they did not receive irrigation water that year because we didn't irrigate high in the basin earlier in the year, and they didn't have return flows. Much of the flows in the Yampa River throughout the later part of the growing season are a direct result of us slowing that water down and its disbursement over our meadows high in the valley for the early part of the growing season. And so that's also could damage what we think of as our riparian areas and riparian health throughout the years, and also what our expectations are. We expect a green valley, and that only occurs because we've irrigated. So this summer definitely provides a glimpse of what that increasing variability could mean. The amount of water that we need and versus what we have, of course, is exceptional. And this year we had great snow, which meant we should have had a lot of water, but that means, which was great, but we also have the timing to deal with. And as Aneesh talked about, as snow melt comes off earlier, it greatly impacts our ability to use it. This is a perfect example. This is the Stetson Ranch pictured here, just above Stagecoach. Bear in mind that if the lower valley floors melt off earlier and we have great snow still up top, we're able to dry out those soils, warm them up, and grass is able to start growing. Then we apply water as it melts higher in the mountains, and we get a good crop. If that timing of melting is compressed in any way, and we don't have the ability to dry out our meadows, warm them, because remember that wet soils are cold soils typically. If we don't have an opportunity to dry them up, warm them up, and then apply water to them, we will not get the production we're used to, and that will forever change the way we manage our ranching systems in the Yampa Valley. And we're just talking about irrigated areas here too. Lack of summer moisture is exceptionally important for all of our rangeland health in our area. And if we have another year like we did, or this becomes more normal, our rangelands will forever be different. Species composition will change, and our ability to graze them will change. I used the photo of the Stetson Ranch to remind me, Frank Stetson, longtime a multi-generational rancher here in Routt County, passed away the first part of this year. But he was quoted as saying, I'd take 2 good rains in May over all the snow you can fit in this damn valley. And that's to be said, you know, we can only mitigate what we can irrigate, but the vast majority, hundreds of thousands of acres that we can't irrigate, do rely on rain. And if we don't get that rain, and this year's a precursor of what's happening, we're in a bit of a pickle. Now, I do want to kind of end on a happy note, although it's with a caveat. As David said, you don't want to be all gloom and doom, but could climate change also bring us opportunities in the ag sector? Yes, absolutely. The possibility of a longer season means we could grow things that we typically don't. There's a reason we graze cattle here. It's because we can grow cool season grasses like no other. But with only 59 frost-free days on average in the Steamboat Springs area, we aren't able to grow much more than that. So could a longer season give us opportunities to grow vegetables and things of that nature? Absolutely, which we're doing right here in this picture. I'll talk a bit more about, but it also means a longer season means we need more water. If we have more growing degree days, so hotter days that we're able to produce, again, more fruits, vegetables, things of that nature, absolutely. Opportunity to do that, it also means more water. And if we have smaller acreages like this one, Be Grateful Farm, which is out in the low mouth of the Oak Creek Canyon, spectacular place. Heather and Jason Rodriguez are doing an amazing job growing local vegetables. But this was, it's important to note, not an area that was irrigated prior to them breaking out and growing fruits and vegetables. So can we have smaller acreages and more intensive crops? Absolutely, but it also means we need more water. So I wrap up here today as we talk about what's changed already and what's staying the same. So if you look at that picture that my mother had on her college wall of Pleasant Valley prior to Catamount, you'll notice that there's grain being grown there, and it's fall, and look how green those meadows were. It's because they were able to be irrigated. And we look today, now that's a different time of the year, but if you were to go out at this same time that that photo was taken in the top right in September of this year, you wouldn't have seen green meadows because we simply weren't able to irrigate. And when I say what stayed the same, here is one thing that stayed the same. This was 2 weeks ago today. I had the great pleasure of taking Colorado Public Radio reporter Michael Elizabeth Sakis out to visit with Matt and Christy Belton, multi-generational ranchers. And as we were overlooking the Middle Fork fire, we were talking to Matt and Christy about drought and climate change and climate variability and how it impacted their operation. And Matt left us with this quote: "Every day that it's a drought, we're closer to rain or snow," he said. "It's not good, but it's a good learning experience for everybody in this business. And maybe next year will be different. That's all we can ask for." Doesn't that sound just like the quotes from the paper in 1923? We're still waiting for next year. We know that there's no such thing as a normal year. There's just a bunch of averages, but hopefully we can remain positive and we can roll with the punches and adapt to what we know is going to be an increasingly variable climate in the future. Great. Thanks, Tim. Appreciate the time.
Thank you, Todd. And I'll turn it over to Lindsay. I think there are lots of questions for all 3 panelists. So that was a wonderful perspective of all the things we're dealing with. So I will trust her to figure out how to best moderate this.
Yeah, so just a reminder, we have all the panelists agreed to stay a little bit longer afterwards if we can't get to all the questions. And if we also can't get to all the questions, we will have follow-up on our website where you can find more information about the Yampa Basin Rendezvous. So we also have an answered question that was typed if you want to take a look at it, Aneesh kindly answered it already, but I'll get to the questions available. Aneesh, are we already seeing changes in El Nino or La Nina related impacts? Can you comment on where the uncertainty and magnitude shifts of El Nino changes might come from here and pass forward to address or reduce that uncertainty?
Thanks, Lindsay. And that's a great question, Anna. I was just typing out the reply and I realized I can answer the question on the panel as well. So in terms of what we have already observed in terms of changes to ENSO cycles, there's no significant change to ENSO cycles right now that we have observed. It's partially due to a limitation in our record of ENSO, but also I think there have been previous studies done with different climate models which show that it can take up to like 200 years to see like a significant shift in how El Nino would change with climate change. And this is talking with respect to how sea surface temperature in the ocean changes when an El Nino or La Nina event happens. Yet there have been studies recently, like even there have been publications in the Nature journal by Wenju Chai and collaborators where they show that the precipitation signal of ENSO changes at a quicker pace due to climate change, and we can detect those signals within this century. Within 100 years, we'll see a change in how precipitation occurs in the tropical Pacific with ENSO events changing. And that has implications in terms of teleconnections to Western US as well, right? Because precipitation is the signal that actually causes atmospheric teleconnections, because that leads to atmospheric waves that can affect Western US climate downstream. So even if the SST change, it's not detectably different over the next century, the amount of precipitation change in El Nino events can imply a change downstream to Western US weather. Hopefully I answered your question, Anna.
Yes, thank you. So this is for Dave. How do you assess which species are at risk or significant, and how are they doing? Are there specific criteria? To clarify, are the questions in the flowcharts representing quantitative criteria?
Yeah, I guess there's kind of two questions there. So to get to the list of what species are at risk or otherwise significant, all the heritage programs have a system for assessing how rare species are based on how many individuals, how large their range is, and looking at the same kind of data that are used to determine, should something be listed as an endangered or threatened species. The heritage programs all maintain databases of what the species are and where they are and how they're doing, and roll that up to create a thing called conservation status ranks. So I mentioned that for the evening primrose that I talked about, having a rank of G2, S2. So it's a 5-point scale, G1 being the rarest, 5 being the most common. So something that is a G1 is critically imperiled and known from usually like 5 or less places in the whole world. We have about 40 plants in that category in Colorado. We've got about 120 that are either G1 or G2 of plants in Colorado. And then a lot of animals in the same boat, but less animals than plants. We have a lot more endemism with plants. So in the questions in the CCVI, I think that was the second part of the question there. Can I show my screen real quick? I just opened up the Climate Change Vulnerability Index and could answer that question.
Yeah, go ahead and share, Dave.
All righty. I think that's the right one. Yeah, so here's the index. It's an Excel tool. It's got this calculator. And the questions, here are the questions, sort of summarized. these other tabs have the gory details of how you answer those questions, but they break down into all the different components of vulnerability. Let me get it to the beginning here. So you start off by looking at exposure using the Nature Conservancy Climate Wizard, which is a really nifty online mapping tool. And so you look at these, you put in, quantitative metrics for exposure based on the results of the climate data from TNC. Then you look at different sort of odd ecological factors. How does the species, feed and pollinate and reproduce? And the tool weights all of those and rolls them up to spit out a score for you that's on that 5-point scale of extremely vulnerable down to possibly increasing. And you can download this tool from the link that's in my presentation if you want to get it and play around with it. It's quite easy to do.
That's great, Dave. Thanks for showing that. We can share the link on the webpage.
Okay.
Oh, questions went away for a second. Dave, this is for you again. Can you describe different management strategies for different type of species loss, or how or if you work with managers to develop these strategies based on the assessments?
Yeah, that's a great question. And this has, the story with the Gunnison sage-grouse is awesome because the in situ conservation we're able to do for that species not only benefits the sage-grouse, but also benefits livelihoods and the resilience of ranchers on working lands in the basin, because when you restore those headwater wetlands, you're fixing the sponge that holds the water up high in the watershed and keeps the creeks flowing longer. So that project is the one where we've worked most intimately with managers on implementing an adaptation solution that really is working. You start to talk about what to do about these extremely vulnerable plants, and you open a thorny bunch of questions about assisted migration. Like, do we want to help these plants get somewhere else? Do we, acknowledging that the climate envelope of this little teeny patch of unique geologic substrate they live on is going to go away? Do we, what can we do to mitigate that? And then looking at landscapes in terms of their permeability for the movement of species is something that the Nature Conservancy just did and released an awesome map of how that might happen and how we can kind of map out conservation that will allow for movement corridors for species and conserve places where we have habitats that appear to be more resilient to climate change than others.
A little to add, do you ever in your management strategies accept species of plants that are normally adapted to a different environment, but as the environment and climate is changing, they have a likelihood of migrating to your location?
Yeah, we've been doing a lot more work lately with restoration and kind of thinking about climate smart seed mixes. So in places where, it's warming up, using seed mixes where you have more of a kind of a warm season grass component in them, for example, than a cold season grass component might help your restoration effort go a lot better. So yes, we're trying to put all of our thinking about that through that lens.
Great, thank you. This one is for Aneesh. Thank you for your excellent talk, they said, from Nathan Stewart. I'm curious about potential linkages between a weakening east-west temperature gradient in the Pacific and winter storm cycles in the Intermountain West. Does uncertainty, CMIP5, hamper our ability to predict how -0.5 to -0.25 changes in precipitation will manifest? Increased likelihood of rain on snow versus, say, snow drought. If you need to read the question again, it's also in the Q&A.
Yeah, no, thank you, Nathan. It's an excellent question as well. It's a complicated question to answer, I should say that. So in our recent study where we used like the CMIPS 6, the Climate Model Intercomparison Project 6th generation models, which is the most recent set of models. Even there, we see that most models do show this reduction in the temperature gradient, in the east-west temperature gradient in the tropical Pacific. So that seems to be an emerging robust signal that the temperature differences between the east and the west Pacific is decreasing in the tropics, which would then imply a weaker Walker circulation. That's a circulation in the atmosphere between the east and west Pacific and the tropical atmosphere. But then how that teleconnects into the mid-latitude jet stream and the cyclones is complicated because of what happens between the tropics and the polar temperature gradient, right? Like there's going to be polar amplification where the Arctic is warming more than the tropics. And that would imply shifts in the jet stream. And there is large uncertainty in the models in terms of projecting this teleconnection pattern with the polar amplification. The polar amplification itself is robust, but how that would manifest in terms of shifting the jet stream is more complicated. So I think there is more work to be done to exactly tell what the changes in the teleconnection would be. But there are indications in terms of changes in the tropical Pacific are more robust, the polar amplification is more robust, and that would imply changes in how the teleconnections that are currently there would change in the future. Yeah, so I don't know if I answered your question exactly, Nathan, but to summarize, there is uncertainty in terms of how the teleconnections would manifest to Western US.
That was from Anna, so I'm sure she will follow up.
Oh, okay, sorry. It said Nathan on the chat, yeah.
Well, this is a question from Kelly Romero-Haney. This actually, I think, can be answered by all the panelists, but can you offer an example of where water, land, or wildlife managers can focus their restoration efforts to minimize species loss in Northwest Colorado? Should I call on someone?
I did nose goes, so I think it's going to be one of the other two.
Yeah,
I think it was specifically addressed to Dave. Anyone else?
I think one of the wonderful things about Northwest Colorado is the heterogeneity of habitats and landscapes, and the presence of water. You know, that's you know, there's kind of a large system there that I think lends a lot of resilience to that whole landscape. So to label one particular place is kind of stumping me. I don't know what that would look like. I mean, I think it needs to be a variety of kinds of different places as a sort of a whole conservation and restoration portfolio.
Any of the other panelists want to address any of that question?
I would just say one thing, Lindsay, in terms of how do we use our limited resources, right, in terms of restoration, I think there needs to be a closer interaction and more collaborations between people who do manage these resources, like water, land, wildlife, and the scientists who are studying how climate change would manifest, especially regional climate change, which is an emerging topic, but a challenging topic for the models to do well. So there needs to be a closer communication and collaboration between both communities, I think, to one, understand what's the signal in the climate change, as well as how uncertain it is, and how do we translate that uncertainty into decision making in terms of making changes to water or land management processes, right?
Great, thank you. Great answer. So I'm going to refer to Tim real quick. He has an announcement to make, and then we can please stick around. The panelists are going to can finish answering questions and talk. And if you'd like to hang out, that would be great.
Great. Thanks, Lindsay. I just want to, just since we're at the bottom of the hour, I do want to say we still have a few questions and we have some time to answer them. So do stick around for at least another few minutes if you have a chance. But on behalf of the steering committee and all of our partners, I just want to thank everyone for your participation throughout this unusual year. I want to tee up the fact that next year we're planning on getting together in person. We're being very optimistic, and we'll have a real blowout rendezvous as we all get together and get back to our face-to-face networking. But it's been wonderful to be able to do this remotely and share with all of you thinking about these really critical issues. Just because we're dealing with an unusual pandemic this year doesn't blunt the need for us to continue to get much better at thinking about how to manage the impacts of climate change across all of our systems here. And this is an amazing group thinking about it, from science, as Aneesh just said, science to land managers to wildlife managers as well. So thank you all, and please do stick around if you have a few more minutes. I know we have a couple questions teed up that I see some for Todd, and then for some, we're gonna have some panelists to ask any questions of each other. So thanks all, and we'll, if we have a moment, we'll continue.
Great, thank you, Tim. So we have some questions for Todd. Sorry we pushed this off to the end, but Todd, do you think the fact that variability is not new for Routt County gives ag producers an advantage towards needing to become ever more adaptive with climate change? Or is the community already at capacity for that? Regardless, from your perspective, what do you see as the way forward? And what are the most impactful uncertainties that need to be resolved?
Oh, there's a lot to unpack there, but I'll try to be concise. So yes, our ag producers will be able to, as they have, and as we saw through the presentation, they'll be able to adjust and adapt, and agriculture will continue to look different in Routt County in the Yampa Valley. I was thinking as we were talking about things that are changing, and interesting as I think about the species change and what David's been talking about, and how climate variability is going to, and change is going to change that. We need to remember how much of our private land is used by wildlife as well, and how it's managed then directly impacts that wildlife. And perfect example, as I showed you the head gate there of the Windsor ditch on Walton Creek, that is the ditch that irrigates the Legacy Ranch. The Legacy Ranch, for those of you who don't know, is that piece of property at the intersections of Highway 131 and 40. There on the northwest corner, if you will, of that intersection. City-owned property that Extension is lucky enough to be able to do some work on right now. One of the things we'd like to try to do there is some forage studies to figure out if we have to cut back on irrigation because of lack of water, and the climate continues to get hotter and drier and we have longer growing season, what are alternative forage crops we can grow there? So we're hoping to do some research there that will help mitigate how agriculture faces this oncoming challenge. And then also point out a perfect example of what happened this year, especially as we look at wildlife. That field is well known for being a rearing area for bobolinks. which are a ground nesting bird that prefer that type of wetland slash hay meadow, open meadow environment in order to nest and rear their young. So the bobolink really haven't fledged and haven't left that area until early to mid-August. I ran out of water to irrigate that area about the 1st of July. So what happens in that month? That means that your hay meadow dries up and what was a viable crop all of a sudden isn't, if we want to preserve that wildlife. So there needs to be conversations around how do we manage for the wildlife values? How do we manage for the pocketbook of the rancher and the owner? And where's the give and take there? Because we don't want to see the flora and fauna change as a result of our actions. And yet, if you've worked all that time to put your money and heart and soul into a crop that you can't harvest, what does that mean? That's not a sustainable business model. So those are some of the conversations we need to have moving into the future.
Thank you, Todd. We have one more for you. And then if anyone has any additional questions, please put them in the Q&A box, or you can raise your hand and speak out loud. And panelists, if you have any for each other, be prepared to talk. Last question for Todd is, what role do cows play in maintaining grassland biodiversity? Can they play a role in climate adaptation?
Oh, that's a great question. So well-managed rangelands can be a great way to sink some carbon. The carbon sequestration of rangelands is excellent but it has to be managed well. And it means not overgrazed, and it means grazed at the right times, and it means the grass is given the opportunity to rest, go into dormancy correctly, and regrow in order to build soil. And then, of course, the carbon in it. One of the things that I'm most concerned about, though, as we look at climate change and variability, is that those rangelands not only need water in order for the grass to grow, but water for the stock used to manage those rangelands needs to be available. And so you can only manage range well if there is the ability to have water for stock to drink there. And that's something that we're going to have to try to figure out how to best do that, so rangelands can be part of this climate solution.
Great, thank you. That's all the questions we have from our guests. So if you guys want to talk to each other, that'd be great.
Well, I have a question I want to throw out, Tim. It's the intersection between every presentation we've had for the last 4 years of this rendezvous has been water. And Todd, you just brought that home. I love that slide where you kept going, means more water. When everything Aneesh and his colleagues are saying is there's going to be less water availability, even if there's more precipitation. I guess this is more a social question than a biological question, but particularly for you, Todd, but others as well. Are we having the right conversations about how we manage water, given the need for it, as it's so critical to both the natural and human managed systems in this valley, and what the science is telling us about both the uncertainty and the likelihood of less availability? I mean, are we even beginning to have the right conversations, or are we behind the curve on that?
I would say, Tim, we're behind the curve. We're also behind the curve on the research of fully understanding the system we've created with irrigation, and the beautiful inefficiency of wild flood, and how that has created an environment, self-created an environment in the last 120 years that we've become dependent on. We don't fully understand what we've done yet, I don't think, let alone where we're going in the future. So I would love to see additional research understanding how alluvial soils hold water or don't. Is conservation a good thing or a bad thing? And when I say conservation, of course, it's a good thing, but if we are more efficient with our water, do we actually increase consumption? How is that all right now? And I'm not sure we have a full picture yet on how that looks. And so, yeah, are we behind the curve, behind the curve? Absolutely, Tim.
Right.
Can I ask another dimension to that? Because you really piqued my interest, Todd, with the when you told us about the role of return flows in downstream water consumption and the situation. And I was thinking about these most vulnerable ecological systems and the woodlands and shrublands along rivers and streams on both sides of Colorado, or one of them that came out in the statewide analysis as being really vulnerable. So I'm wondering what potential there is for those return flows to kind of help achieve conservation goals for those systems. And you know, the natural flooding regime is what perpetuates a lot of these. So and the disturbance resulting from that is really important for establishing new cohorts of plants there. But you know, given that these are you know very human influenced and altered systems now, like what is, I'm wondering if there's a role for achieving conservation goals that we haven't been thinking about enough, that involving these return flows and the way that irrigation water's taken and seeped back in to the system.
Boy, Dave, I wish I had an answer for that. I will say that it's interesting you talk about flooding, and we've helped reduce those flood events due to irrigation, right? Because we're taking the water out of the river and spreading it back out above lands. And that's why we've seen, I think, you know, some of the research I've seen, cottonwood forests diminish because we lack those flooding events. One could argue that that's part related to reservoir storage or irrigation. But then those return flows, slowing that down and adding to riparian health later in the year. I don't know about anybody else, but I'm sure troubled when I see pictures of the Yampa River virtually dried up in the fall. And so as we've screwed with the hydrograph enough, I don't know, Dave, what the answer is. We should have a beer later and we should talk about that.
That would have been the play on a regular run.
Absolutely. We could have solved the world's problems.
Well, I do think, I mean, what I'm hearing here, and maybe we're you know, those of us for the steering committee that are still listening on and thinking about next year, is it doesn't feel, and maybe Aneesh could comment on this, it really feels like the kinds of changes we're facing are outside the scope of what we might have thought about as just adaptation, being more resilient. We really need to be proactive, probably start actively managing systems. So using return flows and irrigation in order to sustain riparian habitat, rather than just hope it starts flooding again, because that's probably not going to happen. But it, you know, it suggests as managers a much more hands-on approach. What Dave described in the Gunnison Basin, which I was involved with, and I think it's an incredible project because it was a win-win. You know, it helped ranchers, it helped wildlife, it addressed a real critical niche in the thing, but it required to go in there and actively manage the system. Now we used low impact techniques and others that got there, but it was also a pretty small part of the overall socio-ecological system that we touched in there. But that's this whole theme of much more hands-on engagement, given what we're learning from climate predictions and models, seems to be a theme for us all. Aneesh, you have thoughts on that? Because you did this big picture from the whole Western US.
Right. Yeah, I agree, Tim. So I think from the climate change study aspects, currently we have a good understanding of the large scale changes that are likely to happen, both from fundamental physics laws that we expect, like if the atmosphere is going to warm, it can hold more water vapor, which can then imply more rainfall in the storms that would occur. So the extreme precipitation could increase if we do have storms that are carrying this water vapor, right? Such as atmospheric rivers. But in terms of impacts in specific regions, I would say there's a lot more work that needs to be done, because these climate models, they are really sophisticated, but they only give us a snapshot of every 50 or 100 miles per what's known as grid boxes in the climate model language. So if we want to focus on specific regions and try and understand the changes in those regions, so regional climate change perspective, both there's more science to be done in terms of running higher resolution models to understand those changes, and then translating those findings of how things are changing on a regional level to not only change our adaptation strategies, like you said, but also like actively think about how do we change our management of all of these, like water management, land management, ecological resource management. So there needs to be a tie-in from both sides, from like people who are managing resources as well as the science needs to be advanced.
Great. Well, that's as good a synopsis of what we've been trying to do with these discussions as I think we could have, and that's really where we look to continue this going forward. There's so much that we're learning every year as we see in these seminars, these rendezvous, but then that just raises more and more the bar for what we all need to do to adapt to it. So I think that's great. Unless there's a burning question from the anonymous group that's still lurking out there, it's hard not to see people. I think I will end it here and let our panelists go. I want to thank you all terrifically, and you would all be getting a great round of applause, I'm sure, if people weren't muted. So thank you, Dave, Aneesh, and Todd, and we hope you can come back in the future and join us.
Hey,
Dave,
Tim,
yeah.
can I offer a better answer to one of my questions?
Sure.
Sort of thinking about that one of where to focus restoration in the Yampa Valley. Thinking back to what I talked about and looking at the vulnerable ecological systems, that the woodlands and shrublands are kind of a no-brainer.
Yeah.
When we've looked at how wildlife utilize different habitats throughout Colorado, over 75% of our wildlife species depend at some stage of their life cycle on wetlands or riparian areas. So if we want to help lots of different things, then focusing conservation and restoration on those areas, no matter what the climate's going to be in the future, is kind of a no-brainer. So.
Thank you for that, Dave. That would have been the answer I would have given too. So again, thank you all, and thank you to the audience that stuck around, and look forward to engaging with you all in some way or another in the future.
Thank you all.
Thanks all.
Thank you.
So I think Anna, I don't know if Sarah or Lindsay are still there. Anna has the control of this and she's gone. So I don't know what happens to our webinar.
Oh, so Mike is,
Mike,
yeah, he's managing from the
so
back.
we can do the recording now. Who's got the recording control?
So I'm on another call too, but I'll stop this one. Sorry for that last 15 minutes. I think this went really great, you guys. I will send it thank yous and more later, but I'll stop us for now, if that's okay.
That is good. We're good.
Okay. Thanks everyone. Thanks so much for serving as moderator today, Tim. This is great. All right. Bye.